Hello guys, Assalamu alaikum. Welcome back to my channel CS by SS, and today we will be talking about algorithm designs and problem solving, chapter number 7. To be the most important chapter for you. So first you should know in this chapter we will be covering all of these things. It's actually program development life cycle. So program development life cycles, it consists on four phases: analysis, design, coding, and testing. In analysis phase, first part is identification and problem and requirement gathering. Once we will do all these things, then design phase, structure diagram, flowchart, pseudocode. Once we will design through these things, then we will do a coding in any high level language. And after doing the coding, we are going to test our code through different techniques. We can use trace tables, we can do debugging, and a lot of other things. So it's going to be the ongoing process or for every module, for every system, right? So let's Hello guys, Assalamu alaikum. Welcome back to my channel CS by SS, and today we will be talking about algorithm designs and problem solving, chapter number 7. To be the most important chapter for you. So first you should know in this chapter we will be covering all of these things. It's actually program development life cycle. So program development life cycles, it consists on four phases: analysis, design, coding, and testing. In analysis phase, first part is identification and problem and requirement gathering. Once we will do all these things, then design phase, structure diagram, flowchart, pseudocode. Once we will design through these things, then we will do a coding in any high level language. And after doing the coding, we are going to test our code through different techniques. We can use trace tables, we can do debugging, and a lot of other things. So it's going to be the ongoing process or for every module, for every system, right? So let's the program development lifecycle analysis phase. First, this is the act of removing unimportant details of the problems to focus on important elements. And examples of abstraction would be the London Underground train route map. Travelers do not need to know the geographical layout of the routes, only that getting on a stop A will eventually transport you to stop A. So see, these are all the details of London underground train route map, but the passengers should not need to know all of those details. And so the first part of this analysis stage is requirements. In this requirements, we will be focusing on two things. First is identification of the problem, and the second is requirements gathering. Identification of problems, before tackling a problem, it needs to be clearly understood by everyone working on it. The overall goal of a solution needs to be agreed, as well as constraints such as limitations or limited resources or requiring a platform specific solution needs to be discussed and agreed on all of those things. Then the next point is requirements gathering. To create a solution, a requirements document is created to define this problem and break it down into clear, manageable, understandable parts by using abstraction and decomposition. A requirements document labels each requirements, given it a description, as well as success criteria, which states how we know when the requirements have been. So after the requirements gathering, the next part is design phase. In this design phase, we will be designing some structure diagram, flowchart, or the pseudocode. And for achieving those things, first we have to do decomposition, right? Decomposition is basically act of breaking down a larger problem into smaller, clear, manageable, and understandable subparts. Subparts can be divided until they are easily solvable and cannot be broken down any further. An example of decomposition could be getting ready in the morning to go to school. For example, there can be more than 6 steps, but I have mentioned 6 steps that you have your target is to go to school. And for achieving that target, first you have to get up, then you have to get breakfast, brush your teeth, put clothes on, make sure the bag and school supplies are ready, and you can find out the transport. You may use these steps. You can change the direction, or you can say that you can do step one instead of step three, or step three instead of step four. It's up to you, but your target can be achieved by following different steps, right? So this is called decomposition. Once the requirement document has been created, developers need to design the structure and algorithm to solve the problem. For this reason, we can do structure diagram, flowcharts, and pseudocode. Structure diagram are created to show the breakdown of tasks in a hierarchy, and flowchart may be created to visually show how tasks should be carried out. And pseudocode is created sometime from flowchart to allow programmer to easily translate task instructions into programming code. The design of a solution identifies what task needs completing, how to complete the task, and how each task works together with other tasks. A computer system includes several components that work together: software, hardware, data, networking, and people. Systems can be broken down into subsystems that can be further broken down into more subsystems until each subsystem has a single purpose. This decomposition is known as top-down approach. So we are actually dividing our problem into many sub-problems. So we are reaching a single purpose solution or a subsystem. This approach is called design. Decomposing a system. To create an overall system and solve a problem, it must be broken down into subsystems that are easier to solve and create. The act of breaking down the problem is known as stepwise refinement. So the decomposition of problem this way creates smaller, more manageable, and more easily understandable subparts. Then each subsystems can be assigned to a developer or a group of developers who create subroutines from these subsystems, and each subsystems can then be created at the same time. It will reduce development and testing time, especially on a larger project. So when a lot of people are working on the same project, but module by module, so it's going to be save our time and development and each and everything. So decomposing the system using stepwise refinement requires developer to think about 4 key areas. There are 4 things you should remember: input, processes, output, and storage. Input means how the data is going to enter into the system. Processes means what are the functions, subroutines, and algorithm that turns input and stored into an output. Output is basically data that is produced by the system, such as information on a screen or a printed information. Storage data that is stored on a physical device such as on hard drives, flash drives, and on any external medium. To solve a problem, all aspects must be thoroughly understood by the developer. There are many methods used to design and construct solution. Three methods are illustrated. We have already talked about the three methods. The first one is structure diagram. So structure diagram show hierarchical top-down design in a visual form. This is your system and you have to divide the system into subsystems. Then each subsystem is going to divide it into more manageable parts. So at the end, we will be getting only one subsystem. At each level, the problem is broken down into more detailed tasks that can be implemented using a single subroutine. As you can see, this is the mobile phone structure, and we have just used some of these things, but you can add multiple things in it. For the voice call, you can set the vibrate, you can set the ringtone, you can receive voice note, you can receive data, you can convert to analog. For sending the voice, you have to first capture your voice, then you have to convert to digital data, and then you have to transmit on internet, right? So there are different phases for doing everything. So structure diagram will tell you the hierarchy of doing everything. Like first you have to get up for going to school, because if you will not get up, how you are supposed to go to school, right? So this is the satellite. This is one of the question. Try to answer this question. A satellite navigation system is an example of a computer system that is made up of subsystems. So part of a satellite navigation system allows the user, so this is going to be our name. Let's just read the question and then identify. Allows the user to enter detail for a new destination or select a previously saved destination and displays direction in the form of a visual map or as a list. Draw a structure diagram for this part of satellite navigation system. So this is going to be our structure diagram name. And as you can see, it's going to allow the user to enter detail for a new destination, right? Or select the select a previously saved destination. It is user input and display directions in the form of visual map or as a list. So these are two options has been given for user enter detail and display direction. So let's see how we can make a map for the satellite navigation system. So see, this is satellite navigation system, this is input destination, and this is output destination. For input destination, they can add a new destination and they can use the previously saved destination, and for output direction they can use map and the list. Everything is given in the question, but we just have to analyze it and we have to make a structure diagram according to them. So in exams they may be asked to, they may be give you the different scenario, but try to sort out all the problems and try to divide your problem into smaller parts, so that it will be give you the clearer picture that what you are supposed to do in your exams. Next is flowcharts. So flowcharts are basically visually representation of any of your solution of your problem. So each flowchart has a starting and ending point with arrow symbols showing the order each task or instruction needs to be carried out. There are several symbols we can use to process flowchart, because flowchart use different symbols to do a lot of things, right? So we will be having terminator symbol. We will be having terminator symbol, also known as begin end symbol. These indicates where a flowchart starts or stops. Process symbol, these shows simple actions being performed, such as assigning value, performing arithmetic operators on value. So all the process related thing, if we are changing some values, we are opening some file, we are doing some process, all the process related instructions will be go in the process symbol. Input and output symbols, it will show the how the input will be taken and how we are going to display the output. Decision making. These symbols used to decide whether to take one or two routes by answering a true or false or yes no question. These can be used for selection and iteration. Last but not the least, flow lines. Flow lines use arrows to show the direction of flow and what task to perform next. Usually these are top to bottom and left to right. As you can see, these are different flowchart symbols we have already talked about. These are just the shapes. You can please note down these shapes. For input and output, this shape key will be used. For process, this shape will be used. And for decision, we will be using the diamond line. And these arrows are flow lines, which is telling you where to move. This is one of the flowchart. We will be talking in detail in the next videos, but this way your flowcharts work, and this way you can create your flowchart. This is the flowchart for finding the largest of 10 numbers. Next is pseudocode. Pseudocode is a programming like language that does not have syntax. It can be considered fake code. It uses English words and phrases to represent instruction and is very similar to programming code, but is not and cannot run on any computer. The purpose of pseudocode is to allow developers to understand how to create a program regardless of the programming language used to implement the solution. So while pseudocode has no specific syntax, it's important to stick to a consistent style. This will make it easier and quicker for programmer to read and create program from the pseudocode. So there are some key points or consistent styles, examples. So as you can see, keywords are written in capital letters. Keywords means all the special meaning words like input, output, if then, else, or for loop, all the things which is having some special meaning in programming language. Variables and subroutines name start with capital letters, for example, name, date, calculation. Indentation can be used for iteration and selection. Next phase of the programming development lifecycle is coding. So developer begin programming modules in a suitable programming language that work together to provide an overall solution to the problem. As each developer programs, they perform iterative testing. Iterative testing means each module is tested and debugged thoroughly to make sure it interacts correctly with other modules and accept data without crashing or causing any error. Developer may need to retest module as a new modules are created and changed to make sure they continue to work, interact correctly, and do not cause errors. Once we have done the coding, next step is to test, right? Once the overall program or set of program is created, they are run many times using varying set of data, test data. This ensures the program or program work as intended as outlined in the initial requirement specification. So for this reason, we use different types of test data to test our code. Or this test data can be include alphanumerical sequence to test passwords, validation routine, and a lot of things, right? For example, the password must be between 8 to 20 characters. So we test data would be passwords of less than 8 characters or greater than 20 characters. Password must include alphanumeric characters means password should be having some non-alphanumeric symbols. Next, we will be talking about some algorithms, built-in algorithms, some standard functions, some standard things, codes we are actually using to solve our different problems, right? So the first concept is totaling. So totaling involves keeping a running total of values entered into the algorithm. An example may be totaling a receipt for purchasing made at the shop. The total below starts at 0 and adds up the user inputted value for each item in the list. For example, if the user has receipt for 4 items, an apple 0.5, drink 1, sandwich 2, and a bar of chocolate 1, the algorithm will total the cost for each item one at a time. The output total will be 4.5. So the pseudocode over here of totaling is total initially total is 0. Then for count 1 to receipt length. So we will be starting count 1 till receipt length, and then We will be running this loop until we will reach this next reach count to receipt length. Then we will be taking input value and we are adding total plus item value. And at the end, we are displaying some output on our screen. I hope you already know all these things, for loop, input, output thing. If you don't know, please go and check my programming video. In that video, I have talked about pseudocode in detail. Next concept is counting. Counting works similarly to totaling, except the count is incremented or decremented by a fixed value, usually 1, each time it iterates. Counting keeps track of number of times an action has been performed. Many algorithms uses counting, including the linear search and binary search, to track which element is currently being considered. The count is incremented and each past number is output until 50 outputs have been. As you can see, this is count 0. This here I am using do while loop. So output count past number, count is 0. Count equals to count plus 1 until count is greater than equals to 20. So this count will run until I will be reaching the value of count 50. And in the below pseudocode, the count is decremented from 50 until the count reaches 0, and output is produced for each pass. As you can see here, I am decrementing, and here I am incrementing. And if I am incremented, then I am checking that it should be reached equals to 50. And here I have changed the signs as well. Count should be less than equals to 0. Initially here count is 50, but here count is 0. So count is just going to be incremented or decremented for the fixed number of times. Maximum, minimum, and average. It's going to be the finding the largest, smallest value in this list is a frequently used method in algorithm. In this algorithm, the initial max and min are set to the first value in the list. And for loop start at the second element to the score instead of benchmark to compare all other elements. If no element is found larger than the initial max, then the max doesn't change. If no value is smaller than initial min, then min doesn't change. The algorithm loop over each element, asking whether the current value is larger than max and whether it is smaller than the min. Max and min adjust their values throughout the program depending on these conditions. The program will eventually output the smallest and largest value in min and max respectively. So for displaying average, we will be needing totaling and counting together. So as you can see here, I'm finding that count, the total value, and then I'm going to divide the total with count and the score size. If you don't have score size, we can use count instead of this. Okay, so algorithm can be used using flowcharts, pseudocode, and high-level language. The purpose of an algorithm is to achieve some goal. It is not always initially clear that what we are going to do and what the goal may be, but by following the algorithm instruction, the purpose can become clear and the final output will be clear at the end of target. So now here I want you to please specify the purpose of algorithm. Take a moment and try to tell me the purpose of algorithm. So we have initialized three values: count, number, total, and then we inputting a user number and adding two variables, count and total, and we are repeating 9 more times, and then at the end we are outputting the final total value. So that's the purpose of this algorithm. I hope you can read it clearly. If there is any confusion, go and check out my pseudocode video in chapter number 8. In this algorithm, please try to find out what's happening in this algorithm. I have used multiple if condition, and I have used one loop. which is repeat loop, and it's going to be repeat until 30, and initially count is 0, and at the end of this count is going to be 30. Next algorithm is linear search. So the linear search is a standard algorithm used to find in an ordered list. The list is searched sequentially and systematically from the start to end, one element at a time, comparing each element to the value being searched for. If the element is found, the algorithm outputs where it was found in the list, and if the value is not found, it outputs a message stating it is not in the list. An example of using linear search would be looking for a specific student name in a list or searching for a supermarket item in a shopping list. As you can see, we are looking for a name Bath, and this is our target. And as you can see, this is, let me show you. This is your array, name with names, and 6 is the size of my array, and these are the elements, right? And this is the index. Arrays always start with 0 index, 0, 1, 2, 3, 4, 5. So what we are going to do, we are going to compare names 0. In the name zeros, it's bath. Is this name 0 is bath, but name 0 is contains gem. So gem is not equals to bath. So no. And names 2, which is Alex. Alex is equals to bath. No. Name 4, bath. Bath is equals to bath. Yes. If it's equals to bath, then I am going to find item to find. Or if it's not found, then I can say item is. So this is all happening in this code. And first we are going to output, enter a value, then we are taking input, and then we have declared a variable found equals to false, index equals to 1, and until repeat until found equals to true means we found the element, or index reaches to the end of list. It means we just reached the end of the list, right? So if number equals to my list index, if means if my list index 1, which is actually 1, not 0, because we are starting with the if index 1 is equals to the number, then I will clearly say found equals to true, else index equals to index plus 1, otherwise moves to the next index. If I found the value, then this loop will be broken, and then we will check if found equals to true. If found is true, then I am going to display number found at a position this index, otherwise I am going to say number not found. So this is the concept of linear search. It's very helpful in our real life, and most of the places we will be using linear search to things. Next is bubble sort. Bubble sort is going to sort item into order smallest to largest by comparing pairs of element and swapping them if they are out of order. The first element is compared to the second is to third to the fourth, and so on until the second to the last is compared to the last. Swap occurs if each comparison is out of order. This overall process is called a pass. Once the end of the list has been reached, the value at the top of the list is now in order, and the sort reset back to the start of the list. The next largest value is then sorted to the top of the list. More passes are completed until all elements are in the correct order. A final pass will check all elements, and if no swap are made, then the sort is completed. As you can see, this is going to be the pass 1 is complete. Okay. So after this one pass, there will be only one element will be sorted out. Okay, so for what we are going to do, first we are going to compare 9 with 2. 9 is greater than 2. Yes, then we are going to swap. And then we will after compare 9 with 4. If 9 is greater than 4, then we are going to swap. So on until we reach to the end, right? In here As you can see, 9 is greater than 10. Yes, it is, but 10 is not greater than 3. Yeah, 10 is greater than 3. We are going to swap. 10 is greater than 1. We are going to swap. So this will happen at end of the one pass, end of the list, first pass done. But this item has been sorted out after one pass. After the second pass, two items will be sorted out from the end of the list. After the third pass, three items, fourth, four items, and so on. So this is the algorithm of bubble sort. Here we have a list containing these items. I have declared an item, first element, and last element is basically length of my list. So what is the length of my list? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So currently my 10 is the length of my list. Okay. So this loop will run until swap equals to false or last element equals to 1. Currently last element is 10. So swap equals to false currently. And here I am using index. First element is 1 and last element means 10 minus 1, which is 9. Okay. So this loop will run 9 times starting from 1 till 9, and we are comparing if my list index is 1 here, okay, and if my list index plus 1 means 2 and 1 is having 5 greater than 9, it's not greater than 9, then we will going to do next index. In the next index it's going to be 2. Then we are comparing 9 with 4. 9 is greater than 4. Yes, it is greater than 4. Then what we are going to do, we have created a temp variable, which is this, and we have placed 9 over here. Okay, and in my 9 index, which is 2, I'm going to save 4. So it means I'm going to save 4 over here, and in this line I'm going to do 9 over here. So swap equals to true, and then again next index. Again here I am going to check with the 3 index. Now I'm going to compare with 9 with 2. Okay, again swap will occur, and 2 will be replacing 9 and 9 will be replacing 2. So this will happen until all of my list has been swapped. Okay, so at the end I am going to display your sorted list is my list. So I'm going to display the sorted list, which is going to be 1, 2, 3, 4, 5, 6, 7. Do I have a 8 over here? 1, 2, 3, 4. Yes, I have 2 twice. 1, 2, 2, 3, 4. 4 is also twice, and then 9. So that's it. After this execution of this complete bubble sort, my output is going to be like this: 1, 2, 2, 3, 4, 4, 5, 6, 7, 9. So that's it. In this way, bubble sort is working. Next, the most important concept, validation and verification. Validation means generally is about making sure that data follows a set of specified rules created by the programmers, right? And verification means is about double checking input data to make sure it's what the user intended to enter, right? So in validation we can have this different types of validation like range check, length check, type check, presence check, format check, check digits, and in the verification we can just double entry checking and visual checks. Validation. So once again, validation is the method of checking input data so that it is of an expected way value and therefore expected by the system, accepted by the system. Programmers create rules using code that automatically checks user input data to make sure the data is response reasonable. If it's not reasonable, then the data is rejected, usually with a message explaining why it was rejected and allowing the user to re enter the data. So, there are different types of validation we have already discussed. Just discuss in detail about the first type, range check. Range check checks make sure that input data is a value between user defined minimum and maximum value. So in the range check, we will be checking the range of our data. Okay. For example, a percentage between 0 and 100 inclusive or a date is in April is between 1 and 30 inclusive. So when we are saying inclusive 0 and 100, it means both of the inputs is going to be between these words. So it means we can enter 0 and 100 as well. So see, for this I have to use if condition, and in if condition I have used if number is less than 0 or number is greater than 100. Okay, so this is going to be if number is less than means less than 0 or greater than 100. If we will add equal sign with these two, this will become inclusive. So for inclusive, I have checked the numbers between number is greater than equals to 0 and number is less than equals to 0, right? Next is length check. Length check is going to be check the exact length of the number, and like we usually use to enter 4 digits pin when we are entering, we are using ATM. So let's check either that the number data is of an exact number of characters or in a user specified number range of characters. A bank 4-digit PIN numbers may be an example of an exact number of characters. If it's not 4 digits in length, it should be rejected. Pseudocode of a length check means, see, we are going to use length function for this purpose, and we will be using, there is an input pin, and we will be checking if length pin means whatever the pin is going to be entered by the user, we will be checking the length of that number. This function will return the number of characters that digit or the word has contains. So if it's not equals to, this is not equals to sign, not equals to 4, then we will be displaying an output, and that's it. Password range. So it's a range check. So in this range check, we usually specify a range, and we have already discussed the range. So move on. Type check. Type check makes sure the input data is of correct data type. For example, someone's age should be an integer, a whole number, whereas their number should be a string, a bunch of characters. So if number, see, there is an input number, and now we are going to check the number of type of that number. If number is not equals to div number 0, so div is going to return a value that's whole number, and if it's not equals to 0, equals to this number, it means this is not a whole number, so you can try again. So in this way we can use to check the type of our presence check. Presence check may make sure that the input data has been entered and the input box has not been left empty. A login system requires presence check as both a username and a password are required for authentication. Let's see, they see I have entered input username, and we are checking if username equals to empty. Means if the username is empty, then we are going to display an error, right? So it means username can't be an empty. Format check. Format check make sure that input data is of a predefined pattern, identification code. Format checks are done using pattern matching and string handling. The algorithm below shows 5-6 digits identification number against the format XX 4 times 9s, where X is an uppercase alphabets letter and 999 is a 4-digit number. The first two characters are checked against a list of approved characters. The first character is compared one at a time to each valid character in a valid char array. If it's find a match, it stops looping and set valid char to true. The second character is then compared one at a time to each valid character in the valid char array. If it's find a match, then it also stops looping and set valid char to true. Casting is used on the digits to turn the digit character into number. Once the digits are considered a proper integer, they can be checked to see if they are in the appropriate range of 0 to 9999. If any of these check fails, then an appropriate. This is the code of checking the syntax or the flow of your characters. We have already explained this in our previous slide, so you can clearly have a look and read it one character line by line, so you will not miss anything which is important to this. Next is check digit. Check digits are numerical values that are final digit of a larger code. We have already talked about check digits in my previous chapters, chapter number 3 and chapter number 1. And it's basically on a barcode. They are calculated by applying an algorithm to the code and then attached to the overall code. Check digits help to identify errors in data entry such as mistyping, misscanning, or misspeaking. Such errors include missing or additional digits, swapping digits, mispronunciation of digits, or simply digits. So this is the code of pseudocode of check digit. You are actually just first calculating the digit and then you are checking that if it's equals to check digit or not. We have already talked about this thing, that how we can calculate in our chapter number 3. If you don't know, go and watch my previous video. Now, the next concept is verification. Verification is the act of checking data is accurate when entered into a system. Mistakes such as creating a new document and entering a password incorrectly means being logged out of the account immediately. Verification methods include double checking and visual. As you can see, first we are going to output, enter your password, then we are taking input as a password. Then we are going to say, please and confirm your password, and the user is going to confirm the password. Then we will check if password not equals to confirm password. Then we will display an output that password do not match, please try again. And this loop will be repeated until password equals to confirm password. Visual checks involves the users visually checking the data on the screen through a pop-up messages or the message, then ask if the user is correct before proceeding. If it's not the user, the enter. If it is not the user, then enters the data again. See, sometimes we saw different pop-ups, like we are saying enter your name, we are taking name as an input, then we are saying your name is this, is this correct? Input yes and no. If the user will enter Y, it means yes. If the user will enter something else, it means no. So this loop will be repeated until user will enter Y. So there is one of the question they can ask this type of a question that describe the purpose of validation and verification checks during data entry. So I hope you are pretty much clear. If you have any confusion, please go back to my previous slides and watch those slides again. Test data. We have already talked about this thing that in PDLC, program development life cycle, we have 4 phases. The first one is analysis, where we are using to identify our problems and we are getting the requirements. Second phase is design, and design phase we are building structure diagram, flowcharts, and pseudocode. Once we have developed to design, then we are going to do some coding. After the coding has been done through different high level languages, then it's time to test your data. Okay, so for testing our code we need test data. So before a system is used, each subsystem must be tested to ensure it works correctly and interact correctly with other subsystems. Programs are tested by running them on a computer device, while pseudocode and flowchart must be dry run manually. Both require suitably chosen and different sets of test data. The output are then compared to the expected output to check if the algorithm works as intended. There are four types of test data: normal, abnormal, extreme, and bound. Normal test data is the data that a system would be expected to handle on a day to day basis in a normal condition. Be expected by the algorithm and produced expected results. For example, it could include entering person's people's name and address, phone number, grades as a percentage, etc. Student percentage grade would involve test data like 34, 41, 56, 78, and so on. Abnormal test data, also known as erroneous data. Abnormal test data is data that is expected to fail and should be rejected by the system. This is used to prove that the system works correctly by rejecting incorrect data. Examples of abnormal data would be entering numbers instead of someone's names or entering text instead of numbers. So, entering any data other than the normal data is basically the abnormal data. So, if they are expecting to enter your age and you have entered your name, if they are expecting you to enter your Gmail and you have entered your name over there, so this type of a data is abnormal test. Extreme test data is the maximum and minimum value of a normal data that are accepted by the system. Examples could include percentages 0 and 100, days in April 1 to 30, and the number of characters in a password range. For example, an 8 to 20 character range password. A password of 8 characters and another of 20 characters would be tested. Boundary test data is similar to extreme data, except that values on either side of the maximum and minimum values are tested. The largest and smallest acceptable value is tested, as well as the largest and smallest unacceptable values. Means in boundary test we will be testing both of the largest value, acceptable and not acceptable, smallest and largest. For example, a percentage boundary test would be 0 and -1 for 0 and 100 and 101 for 100. For the days in April, 1 and 0 for day 1 and 30 and 31 for day 30 would be tested. In this, 1 is acceptable and 0 is not acceptable. 30 is acceptable but 31 is not acceptable. Same with the password as well. Okay, so for the test data, they can ask this type of a question that a programmer has written an algorithm to check that prices are less than $10. These values are used as a test data. 10.00, 9.99, 10. State why each value was chosen as a test data. So you have to find out the reason of every chosen value. I have already explained. Trace tables. So the most important concept is the trace table. Whenever you have drawn a flowchart, so then you are going to test your test your flowchart through trace table. This process is called dry running. Trace tables are used to follow algorithms and make sure they perform the required task correctly. Test data is usually used in conjunction with the trace table to ensure the correctness of the algorithm. Manually tracing an algorithm with test data in this way is known as dry run. Trace table can be used with flowchart or pseudocode or even real code if necessary. Trace table can also be used to discover the purpose of an algorithm by showing output data and intermediary steps. Trace table record the state of the algorithm at each step or iteration. The state includes all variables that impact the algorithm output as well as the output itself. A trace table is composed of columns where each variable and output is a column. Whenever a value changes or an output is produced, The relevant column and row is updated to reflect the. So this is one of the example of a trace table. Okay, so this flowchart is going to determine the highest number of 10 users entered name. The algorithm prompt the user to enter the first name number, which automatically becomes the highest number entered, as you can see in this, right? The user is then prompted to enter 9 more numbers. If a new number is higher than an older number, then it is replaced. Once all numbers are entered, the algorithm output which numbers was the highest. So this is the test data. Test data will be given to you in your exams. So by using this flowchart, you have to test this data on this flowchart. How you are going to do this? See, in the first, it's going to start. There is a variable count. I have declared count as a column name. Then there is an output, enter 10 numbers, output column, enter 10 numbers. Again, output, enter your first number, input highest. So, highest is my variable. I have named this as a column, and here I have mentioned the variable which is given in my test data. Count equals to count plus 1. So, I have already I have 1 as a count value, so I'm going to add one more and it's become 2. And number is greater than highest. Do my number is greater than highest? Okay, so here there was a highest value as well. Number is 3 and highest is 4. So is it greater than? No, it's not greater than. So count is less than 10. Yes, it's less than 10. So again, I'm going to go there. Enter next number, enter your next number, and input number. I have entered 7 and so on. In the same way, I'm going to run this trace table to find out the highest number from this through this algorithm. This flowchart presents an algorithm. The algorithm will terminate if -1 is entered. So this is your test data and this is your flowchart. Try to run this and execute this. You have 5 minutes, 30 seconds. You can take some time. You can pause my video and then take some time to run this code. It will actually take 10 to 15 minutes. This is the output. If you got the same output, then it's very good. If it's not, then do let me know in the comment section box what's gone wrong where. Okay, once we have developed all the cycles, we have tested algorithm. Now it's time to identify errors. Errors are basically any type of a problem in our systems. Error can be identified in algorithm using trace table as well as scanning and debugging code manually. Two types of errors are as follows: syntax error and logical error. Syntax errors refers to the grammar of language, that's are the words in the right order and is everything spelled correctly. Unlike programs written on computers, syntax error in flowchart and pseudocode do not cause the algorithm to fail. However, they do make the code more difficult to read and understand. Transcribing flowchart and pseudocode to real programming code may cause problems if it is difficult to read and understand said flowcharts and pseudocode. Logical errors. Logical errors occurs when the program finishes but produces the wrong output during or after. Flowcharts and pseudocodes, unlike real program, do not crash when dry run. However, may still produce logic errors by producing incorrect output. Logical errors are the most difficult errors to fix, as a developer must reconsider their logic and processes. If they do not understand the problem, they cannot produce an accurate solution. Say the program will be given to you, and they are supposed to ask you to find out the errors in this code. So algorithm that ask the user to enter their age to determine what rated movie they would watch at the cinema. There are syntax and logical error with this pseudocode. Take your time, read this code, and try to answer this question. So, syntax error is in the line, yeah. Syntax and logical error, output age and input enter and age are both syntax and logical error. How it's going to be syntax and logical error? Age does not yet have a value, so output cannot be displayed. See, this age is a variable and output and input. The first two lines both are incorrect because this is variable and we cannot output the variable until or unless we have the value in that variable. And it's clearly that there is no input in here, so we have to use actually then is missing from the first if. This is your first if and there should be a then over here, and because it's the syntax, as you can see, if then, so here then is missing. A code is missing from the output. You can watch a 15 movie. Oh yeah, here, see, the double quotes are missing at the end of this. And logic error, age less than 9 should be greater than 9 so that it follows the other if statement logic. Here, age less than 9 means age less than 9 should be age greater than 9 so that it will be follow of other the statements. And again syntax if and if is missing from the first if for this if and if is missing. So, and algorithm has been written in pseudocode to input some numbers. It only outputs any number that are greater than or equals to 100. The numbers 999 is not output and stops the algorithm. So, identify the 4 errors in the pseudocode. They have already given you the code and they have already given you the problem. So, you are going to identify the 4 errors in the pseudocode and suggest correction. And write a pseudocode statement to change the corrected algorithm to output all numbers between 100 and 200 inclusive. Don't forget this word inclusive. Inclusive means 100 and 200 will be included. You do not need to rewrite the whole program. In fact, just find out the errors and then fix those errors. See, the 4 errors has been given over here and the new program has been given over here, right? If number is greater than equals to 100 and number is less than equals to 200, then output number. Okay, so the most important tips and tricks for writing and amending your algorithm is that to create algorithm for a given problem, several stages must be followed. The program must be sufficiently analyzed and understood. The requirements and the purpose of algorithm must be clearly stated. The problem must be sufficiently decomposed into subproblems. A complex problem may require many subproblems, with each subproblem requiring their subproblems and algorithm. When determining an algorithm for a subproblem, developers needs to consider inputs, output processes, and long-term data storage if necessary. Consideration must be given to how data is going to be gathered, stored, and processed, as well as how output is going to be displayed to the user. The structure of the problem and subproblem should be illustrated by creating a structure diagram which details the breakdown and hierarchy of subproblems. Once each subproblem is specified, an algorithm can be created using flowchart or pseudocode. The algorithm should be clear, easy to read, and as simple as possible. Meaningful names should be used so that readers understand what data is being stored and their purpose. Use of mathematical symbols because it's easier and quicker to read and it's easy to understand rather than the equal to, less than, or equals to. Sets of predetermined test data should be dry run on the algorithm, including normal, abnormal, extreme, and boundary data. The results should be displayed in a trace table with clear output to allow errors to be detected. Encountered errors should be fixed and the Algorithm retested to make sure its functions are intended. So there are some exam tips related to chapter number 7, paper 2 basically. Writing algorithm in an exams can be challenging and time consuming. It's important to allocate your time carefully to not spend too little or too long writing an algorithm. You will likely make mistakes and rewrite your algorithm a few times. Use scrap paper or the back of your exams paper if possible to sketch out your ideas before committing to your answer. This will make your answer sheet clearer, neater, and easier to read, follow, and understand. You may wish to chunk your algorithm into parts initially. For example, this part will enter the grades, this part will calculate the total, and this part will allocate grades. You can then put the whole algorithm together in order later. Make a plan before you start answering the question and write your algorithm. A plan can be simple but allows you to order your thoughts. For example, in part 1, you are going to declare an initialize variable. In part 2, allocate marks for each subject. Part 3, allocate grades for each student subjects. Part 4, include a loop. And part 5, output all necessary data. Usually, pseudocode doesn't have a syntax, therefore, you can write an algorithm in any way which is easily understandable. Caution is advised to stick to IGCSE specification standard to ensure your answer is consistent and easy for examiner to follow. Be sure to use variables names and data provided in the question as given. Failure to do so will lose your marks. Remember to comment your code. It helps both you and the examiner understand your answer and also award marks in the mark sheet.